For solar DIYers, one expensive item is to buy copper wires, especially when you need to carry a high current. You need to buy a big fat copper wires. They are typically very expensive. Also, the busbar for the batteries, they are typically also not cheap if you need to have big ones that carry higher currents. So usually when you buy the batteries, they come with busbars like this, but sometimes you need a custom sized length that you might want to make by yourself, and it happens that you have some copper pipes around. Like in my case, I have some 3/4 inch copper pipes and also 1/2 inch copper pipes. This bizarre color is because they have been very dirty, and I put them in vinegar to clean them up. They become this pale color like this. Anyway, so the question is, how much current can such pipes carry? So you might wonder, what is the AWG, the American wire gauge, for a typical 1/2 inch L-type pipe or a 3/4 inch L-type pipe? For that purpose, I'm going to make the calculation for you guys. So you have to go first to the copper tubing data. So what I'm interested in here is the 1/2 inch copper, and I'm interested in the outer diameter. In this case, it's 15.88. I'm also interested in the wall thickness. In this case, it is given as inches, 0.04. The other one I'm interested in is the L-type 3/4 inch pipe, and the thickness is the diameter is 22.23, and the thickness is 0.45. So after that, I did some calculation, which is somewhere here. Okay, so the red colored readings are the numbers I got from the previous table. So the out diameter is 15.88 millimeter, and the wall thickness is 0.04 inches, which translates to 1.016 millimeters. So this is for 1/2 inch L-type copper pipe. And I also would like to calculate the inner diameter, which is easy. That is to use the outer diameter minus 2 times the wall thickness. So that gives me 13.848 millimeter. So with this inner and outer diameter, I can calculate the circumference. So the circumference for the outer circumference is like 49.86 millimeter. The inner circumference is 43.48. So with that, I can multiply that to the thickness. I can calculate the cross-section area. If I were to use the inner circumference, I would get 44.2. If I use the outer circumference, I would get 50.68. So this is the upper limit of the cross-section area, and this is the lower limit of the cross-section area. The units is millimeter squared. So now if you go to the American wire gauge, so you can find out the cross-section area of the wire gauges. So you can see that for the number 1, the cross-section is 42. And for number 10, which is 53.5. So in other words, for the number 1, the maximum current is kind of 120. The other one is 150. So that's why, based on my calculation, the wire gauge is between 1 and 10. So the current that is safe for you to carry is, I think, something like 120 amps, which is good to know. That's just a half-inch L-type copper pipe. I did the same calculation for the 3/4-inch pipe. So the only two numbers I got from the previous table was the outer diameter, 22.23, and the thickness was 0.045 inches, which is 1.143 millimeter. So I just did the same calculation as in the previous case. So I found the cross-section area is between 71 and 79 millimeters squared. So if I go back to that table, so I find that it is between 20 and 30, basically. So with the currents, the 20 allows 190 amps, and the 30 allows 239 amps. So if you want to play safe, you don't want to go to the higher number, but going to the lower number, like something like 200 amps should be quite safe. If you still feel unsafe, you can put a half-inch pipe inside a 3/4-inch pipe, which is huge. That would give you huge amount of cross-section area. So I felt that it would be nice to know this information. If you really, like me, I occasionally use the leftover copper pipe to do a few things in my solar system. So I think this information is very useful. Thank you for your attention.